Today's session, day 2 of the 4th Industrial Revolution Summit. Because we are doing industrial outside the current voice on the platform. Thank you. It's day 2 of the summit this morning. Thank you so very much for making it on time. We humbly want to apologize that we are starting a bit out of the initial time, but just to recap, yesterday we had an honor of being addressed by the Minister of Communication, the Premier as well, and there was a dinner later on the day. We also had the Commissioner from Ghana addressing us last night. So today it will be more on commissions. I hope and I believe that our energy is ready to engage the content this morning. The second Free State Industrial Revolution Summit, which talks to accelerating economic growth and development of the Free State through innovative 4IR technology. This is not just a talk shop. A lot of people may want to say, well, government do host the summits. What do they produce? In 2019, there was a provincial summit, which we are proud to update and report that today in 2022, the 2019 Free State Provincial Summit was able to produce the Free State Artificial Intelligence University. This was together with the CUT and Microsoft South Africa. We can also talk about the Botshabelo Digital Hub, which was also in partnership with CEDA, the Small Enterprise Development Agency. We can talk of the introduction of the 4IR training that specifically focused on the lower level government workers. This talks to the cleaners, the security personnel, and this is also been in partnership with CUT as well as NEMISA. And the other program that was as a result of the 2019 summit, it's the data-driven state-of-the-art COVID-19 war room with University of Free State and Vodacom. We are hoping that when we come back in 2023, we should be able to say the 2022 4IR summit has produced the following programs, and that of course will be presented in 2023. And for today, it's a Friday, technically, traditionally, culturally, a short day, psychologically and mentally and otherwise. We are here. I'm glad that Dr. Naidu is joining us virtually. Tate Stolle is also here with us. He's going to be talking to us from the Presidential 4IR Commission. We also have presentations from Blockchain Smart Contract. We've got Ntate Mokwalusi, who's going to be talking to us, as well as Dr. Munyani. We've got the presentation from Smart Water Bottling Plant that will be delivered by Dr. Kuriakose. Did I do justice? Thank you very much. We also have the presentation from Prof. Lewis, Solar Car Project. Then we are going to break into commissions. The first commission would be here, and the second commission would be at the Prosperitas Auditorium. So, if you would be interested in the education, training, and employability, this would be the venue. If you are interested in engaging on the commission that will be looking into
so
the
that-
healthcare, we will be right here at this plenary venue. And these are the two commissions that will kickstart our day. We will later on have another commission with just two venues. It's this venue and the other venue. Please don't get lost. Our officials are also here to help us with directions when we move from one venue to the other. Ladies and gentlemen, if we may, without wasting any of time, if we may all rise and just observe a moment of silence, and we officially kickstart our program. Thank you. Our first speaker this morning, the Fourth Industrial Revolution Summit, will be Dr. Naidu from Gendermark. He'll be joining us virtually. Dr. Naidu?
Good morning, everyone. I just want to do a sound check and a video check to see that everyone can hear me. If somebody can give me a thumbs up and some feedback, please. Okay, I assume that everybody can hear me and see me. So firstly, thank you for the opportunity. I only have 15 minutes, so I'm going to try and kick straight into it. So Gendermark Automation is a business that designs and builds production lines. We've been doing this for around 30 years now, and we have a business in South Africa, a business in India, as well as a team of 650 people. Our turnover is around 55 million euros. And very recently, we've actually started a digital services business that's focusing on the fourth industrial revolution, but in particular, the fourth industrial revolution for Africa. And that's what I want to focus on in the next couple of slides. This is a brief history of Gendermark. And as you can see, we started in 1989, and we've actually designed and built machines for different countries. We have an office in Germany. We have a factory in India. The one picture I do want to show you is something that we're very proud of. Here's a machine designed and built in South Africa by our team here that's actually exported to VW in Germany. And what's really significant about this machine is that it's what we call an autonomous production line. So there's actually no people on the production line. So it's one of the state-of-the-art production lines that's running in Germany, but built in South Africa by our team, and something we're very proud of. Some of the other things that we've been able to achieve in the last couple of years is a 90% export. So 90% of the equipment that's built in our factory in South Africa is actually exported all around the world. And what we've learned over the last couple of years is that our experiences from different countries, from India to South Africa to China, USA, Germany, really brings us back home to Africa. And we have to ask the question, what have we learned over our experiences over the last 30 years, and how do we apply these technologies to really answer some of the African challenges that we have? And I don't need to talk about the challenges in this forum. I think people are well aware of it. So what I try to explain to people is the differences in situation between Africa and Europe. And the way I do that is I use this population pyramid. So this is a population pyramid of Western Europe that shows that the populations are getting smaller and smaller. So this is the younger people, so from 0 to around 20 years old. And this is the working world. So this is around sort of 25 to 65 years old. And as you can see, the top part is bigger than the bottom part, which indicates to us that populations in Western Europe are getting smaller and smaller. And if you look at the fourth industrial revolution, or in Europe as what they call it, Industry 4.0, the problem they're trying to solve for this population is to do more with less people. And you see that a lot of the technologies is all centered around automation and this paradigm of doing more with less people. But let's take a look at what the African population pyramid looks like. So this is 260 million people. and this is 1.3 billion people. And you can understand that if we copy and paste these solutions onto this population, we'll have a huge disaster. And what's even more crazy is that this population is going to spiral to around 2.2, 2.5 billion people in the next 20 years. So we have an even greater challenge on our hands with this fourth industrial revolution if we copy and paste what is being done in the Western world. What we have to do from an African perspective is completely change the paradigm and really understand that this bottom half of the pyramid in Africa is actually an opportunity. And how do we use digital technologies to unlock this opportunity? And so to do that, we have to change our mindset first. And so we have to change the paradigm. What we have to say is that we have to use technology to do more with more people, as opposed to using technology to do more with less people. And unless we adopt this mindset, we are creating more and more problems for ourselves in Africa. And the other point that I want to make with these two population pyramids in front of us is the solution is not going to come from the Western world or the developed world. The solution has to come from us because they're dealing with a different challenge and they have to deal with their challenges. And we have to deal with our challenges, but we can use technology, the same technology in a different way to solve our particular problems. And the next couple of slides is really some examples of how we do that. But before we go into that, I just wanted to illustrate, this is an article that came out of The Economist last week, actually, that talks about population growth for the next 80 years. And as you can see, I've drawn a line over here at around 2050, which is not too far away, 28 years away, actually. And so I want to illustrate and use this chart to make the point again, is that for this top half, the solution is automation. And what we have to do here for the top half is do more with less people. However, the majority of the world, and I really mean the majority of the world, has a different problem. We have an abundance of people, an abundance of human capital. So we have to use technologies around digitalization to do more with more people. And for us, there's a distinct difference between automation and digitalization. In Africa, Southeast Asia, India, for example, we need to do more digitalization, whereas in the developed world, the USAs, the Europes, the Japans, they have to do more automation. And this is an important distinction that I think a lot of people don't understand, where what we try to do from my perspective is we try and copy and paste what the advanced, so-called advanced countries are doing. And if we copy and paste what they do on our society, we have a huge problem. And so our argument is that we need to do it differently. We need to learn from what they've done, use the technologies, but apply it differently. And I'd like to share with you some examples of how this is being done. So this is a picture that shows a number of brands and organizations that are present in South Africa. And the circles actually represent the number of people they employ. So we have this mindset that technology will make jobs obsolete and take jobs away. But my question to you is, can you match these organizations to the size of the circle? And the size of the circle represents the number of people they employ. I'll just leave it there for a second, just for you to think about it. So which of these organizations belong and essentially employs the most? So here's what it looks like. So in actual fact, over the last 8 years, Uber has created 13,000 opportunities for new people to earn a living versus some of the big known brands. In fact, some of these big factories have actually been reducing the number of people they employ. As they grow, they automate. And so they are now actually taking people out of their factories and doing more automation. Whereas if you look at a digital business like Uber, has actually created a new market segment and has actually created 13,000 jobs in South Africa. And what's really even more interesting about the Uber analogy is that they have created 13,000 jobs with no government assistance. So no money from the Development Bank of South Africa, no money from the IDC. They came into South Africa with a digital business and were able to create 13,000 opportunities for new people to create and earn a living. It may not be direct employment in the conventional sense, but we need a new mindset in terms of creating opportunities for people to earn a living. And Uber is a good example of a digital business that has created that. So what we are doing at GenderMark is we've actually created a number of different apps that are focused on manufacturing at this stage to solve the skills challenge in South Africa and really to try and create opportunities within factories in South Africa to unlock the potential of humans within a factory, not take humans out of the factory. And I want to give one example of a scenario. So here's a person we know, his name is Goodwill. And as we all know, the youth unemployment in South Africa sits at 75%. So Goodwill is a good example of somebody that wants to work, but unfortunately doesn't have the education to actually perform the tasks in this factory because he hasn't gone to school, he hasn't gone to university. So what we've done is we've created apps to empower Goodwill. And I'd like to share some of these apps. So the first app I'm going to talk about is Odin Vr, or Odin Virtual Reality. So over here, you see Goodwill is now learning how to operate an assembly station inside the factory. So you can go into virtual reality, learn the process. And in fact, within the virtual reality, we have tests within the applications to check whether Goodwill is performing the tasks correctly, to see the speed at which he's performing the tasks. And so Goodwill can actually practice these tasks with coming in at zero skills. And so he can practice and practice and practice. And the system determines whether Goodwill is now capable enough to go and work on the actual production line. So once he gets to that point, he can then go onto the actual production line. And here you see what we call digital work instructions. So you can see in front of him is a visual image of what he needs to do when he needs to do it. And this is exactly what Goodwill saw in the VR simulation. So there's nothing new that he's now experiencing in the physical world. So the instructions are given in a pictorial form or in whatever language that Goodwill prefers. So you can change the different languages. And the most important part is that we've been able to connect the hardware on the station. So whether it be a measuring device or a bolting tool or a barcode scanner, it doesn't really matter. So we are monitoring the performance of the hardware and only ensuring the process continues when the hardware has told us it's okay. So in this example here, Goodwill can scan the barcode. If he scans the wrong barcode, the process doesn't continue. The analogy that I tell people is that it's like Google Maps. So you want to go from point A to point B, and you're now in your car, and then you realize you missed the turnoff. And immediately what Google does is it recalculates using AI to redirect you to the quickest, best path back to get to your final destination. And that's exactly what our system does, is if Goodwill makes a mistake on the station, we're able to detect that and ensure that the next steps are dynamically created for Goodwill to get the part that he's producing correct again. And then we've taken one step further where we now use AI and computer vision to actually detect different elements within the station. So over here, you see we are able to detect the bolting tool that Goodwill is using. So if Goodwill has now positioned the bolting tool in the wrong position, for example, we would disable the bolting tool so that he can't bolt the bolt in the wrong position, as a simple example. You can see over here the bins where he picks the components. So we're able to detect the Goodwill's hand as he picks the components. And so if by mistake he picks the wrong parts, we're able to indicate to Goodwill and redirect him to pick the right part. You also see over here a virtual button. And what this does is it actually takes away the need for a physical button now, and we can actually detect the finger using AI. And by him pressing the sticker, not the button, we're able to sequence the process to the next step. And so as a consequence of this, we achieve two things. The first thing we achieve is we ensure the process is maintained, the security of the process is maintained. So we can take an unskilled person, make sure that they can perform the tasks, and AI is enabling that person to perform those tasks. That's the first thing. The second thing we do is this station has got 2 cameras above it and very little hardware. So we now no longer need expensive control systems. We don't need any expensive wiring. We don't need expensive programmers to commission this production line. And so this physical station is now 50% cheaper than conventional automation solutions. So not only are we enabling an opportunity for an unskilled person, but we're also reducing the price of manufacturing by reducing and using AI. So this notion that technology is going to make things more expensive, technology is going to take skills away from, will require higher skills to perform tasks is not true. And we've proved this in multiple locations around the world, actually. And the last part that I wanted to share with you was about data. So obviously big data analysis. So as a result of the station collecting lots of data, we're able to instruct Goodwill directly to say, okay, Goodwill, you're doing really well on your barcode scanning operations. And here we can see the time that Goodwill takes to perform barcode scanning operations is going down, which means it's getting better and better. But we can see at the bottom over here with the red line going up, it means that Goodwill is taking longer and longer to perform the bolting operations. So something is obviously going wrong there. And what we're able to do is dynamically feed that information back into the virtual reality system and tell Goodwill on his mobile phone that he should go for further training in the virtual reality simulation. And so we basically close the loop on skills development. And this is what we call the Smarter Worker platform. It doesn't mean that you need high skills to do this. In fact, we start at the point where you have 0 skills and you're now able to perform these complex tasks. And for us, this is the opportunity that technology presents. It's not about creating and taking opportunities away. It's about actually creating opportunities for the demographic and the society we actually live in. I wanted to create show a little picture of what Uber actually looks like from a technology perspective. So you see Uber in the center, and you see all of the different technologies that are Uber have used to actually develop their system. So things like Google Maps, we're all familiar with, cloud computing, AI, the app stores. These are all the technologies that Uber created or have used to create their application. And the reason why I want to show this is because I want to show you, this is actually a gentleman from the Free State. His name is Tsepiso, who was laid off from his job where he was, they were manufacturing washing powder. And now Tsepiso lives in his community, and he actually manufactures washing powder and sells the washing powder to his community. So I wanted to use this as an example because Tsepiso is actually from the Free State, to show that what if we built a digital network around Tsepiso? So we create a machine that's got advanced AI and computer vision to ensure that the process is correct. But we take that one step further where let's call it Uberize Tsepiso's washing powder manufacturing. So we create an app where people can order the washing powder. We create a rating system. So where Tsepiso does a good job, people can give him a 5-star rating, like what we do with Uber. We can use cloud computing so that it's scalable, not only to Tsepiso in one location, but to multiple locations. And then most importantly, we are able to connect Tsepiso to experts. So the formulation, for example, of the washing powder can be SABS approved by SABS and some experts, can be downloaded to the machine, and Tsepiso simply follows the process of what's on the machine. And so essentially what we've now done is we've Uberized washing powder manufacturing. And so we can then potentially copy and paste this to multiple societies in South Africa and in Africa, where people can now create their own washing powder manufacturing business, as a simple example of the opportunity for digitization. And this can then be scaled to different types of manufacturing. Let's call it dressmaking, let's call it brick manufacture. And the list is endless. So this is an example of what we call network manufacturing or distributed manufacturing, and technology is enabling us to do this. The next and the last 2 slides that I wanted to share with you is this idea about network education. And again, you see in this picture a similar idea to the Uberization of education. So here's a device that we've developed, and in fact, I'm very proud to say that the first rollout of 600 kids was actually in the Free State. So we call it Omang, which means obviously identity, and it's a closed device. So kids that get this device are not able to access the open internet. It's actually a closed device. We have support from both Vodacom and MTN for network and connectivity and data. We have online classes from Big Blue Button, which is the same as Zoom. And most importantly, we have this idea of web platforms. And web platforms is a very powerful thing because we want to flip the classroom around. We don't want to give kids the exact curriculum that they should learn, whereas we want kids to become creative and allow them to explore and determine what and identify what they're interested in. So for example, on these web platforms, we have things like Siavula, which is adaptive maths learning. We have things like SpaceX, we have things like NASA. And from these web platforms, we actually have big data analysis, and we have built a recommendation engine from all of this, where we now create a unique profile for every child on the platform. And then we dynamically change the information on the device to what the child is interested in. So as an example of this, what we found is that a lot of kids are actually interested in space. So we see the amount of time they spent on NASA and SpaceX, and now the latest Webb telescope information. And so what we can do with that is we now identify these tags and the metadata within these applications we call, and we link them all to the subject of cosmology, so stars and space. And what we're able to do is create a heat map of the thousands of kids on these devices to see which kids are actually interested. You see at the bottom over here, so the more kids, the dots on the one side of this axis are much more interested in space and cosmology. And on this side, we see kids with aptitude for things like maths and science. So we can see obviously the results of the tests on the device. So when they do a maths test or physics test, it means they have aptitude for maths and science. And so what we can now do is we can actually stimulate the kids in this quadrant to maybe move towards more things in SpaceX and NASA, for example. And the kids that are really interested, we can also stimulate them and help them more with physics and maths. And what we can then also do is we can then create a digital community of kids around the whole country that are interested in cosmology and create a sort of stars club or cosmology club. And all of this is possible because we've been able to Uberize education and distribute these tablets. And what's really crazy about this is that we're able to do this for $500 a year per child, which, and if I know the stats correctly, that's a little bit more than what our government is spending on textbooks for these kids. Not only do we give them the textbooks on the device, digital versions of the textbooks, but we actually take the education to the bare minimum, but to the extreme where they now have the most advanced education in the world for cheaper than anybody else can do in the world. And that's the advantage of really understanding the opportunities of digitalization versus automation. And we really believe at GenderMark that digitalization presents huge opportunities for us in Africa. It's about us understanding the opportunities and really accepting that it's the bottom half of that pyramid is the opportunity. And I'd just like to close with obviously this slide again, just to ask the question, are we ready for this new world that we're in? Because this is the world we need to focus on and not copy and paste the top solutions onto this bottom half of the world. And I'd like to end off with that. I'd appreciate it if you scan the QR code. That's how you get access to my personal webpage, as well as you can follow me on LinkedIn. Thank you very much, and I appreciate the opportunity.
He is asking a fundamental question, that are we ready for this world that we are in? Are we ready? In 2019, President Cyril Ramaphosa appointed the members of the Presidential Commission on 4IR. And I think that was in response to the question that Dr. Naidu is asking. But later on, during the State of the Nation address, the president said South Africa had chosen to be a country of the future at a time when the world was changing at a pace and also in a manner that was unprecedented in the human history. Joining us this morning from the Presidential 4IR Commission, it's Ntate Phila Sithole. He is at the level of strategic implementation plan, and we want to hear from the government point of view. Where are we in as far as South Africa is concerned when we are talking about the fourth industrial revolution? Ntate Sithole.
Program Director, thank you very much. Representative of national departments, provincial departments, Prof. Goi, the Vice Chancellor, our distinguished guests and our speakers, all protocol observed. it's a great pleasure to be here and to see that the province is taking steps to ensure that they take opportunities of the fourth industrial revolution. In 2019, His Excellency President Cyril Ramaphosa put together a group of experts from various industries to put together a strategy which formulated into the PC4R report, which was gazetted in 2020, and it was since been published, and the Department of Communication and Digital Technologies was tasked to put together an implementation plan for that. And since then, that plan has been published, and it has been available for the public. But just a step back, the President put a statement that we should take the opportunities presented by 4IR, especially for young people, as a skills revolution that will enable us to quantum leap into the economy of the future. I think that is very critical, that there is an economy that we can tap to that is going to propel us for job creation, that's going to propel us to fight poverty and inequality. Since then, when we put together the implementation plan, we consulted various stakeholders, various provinces. We also went to clusters. We also went to the private sector on how to put together programs that are going to propel us forward. And we also had to ensure that we have a time frame actionable 4IR path for South Africa. We identify existing and future programs, because some of these programs have been existing. We need to integrate them into a national plan. But we need to identify challenges within the high growth potential economic sectors in public institutions and propose 4IR technology solutions that holds the potential to address those challenges. We need to outline collaborative structure for all stakeholders to work together. We also need to have an 4IR awareness and engagement across stakeholders. But what is important, we need to have it outlined in the MTSF that that is a plan of government. Just in an overview, the framework of the strategic implementation plan addresses what needs to be prioritized, digital infrastructure, human capital, according to the recommendation of the PC4R report. But we also look into Industry 4.0. What are the industries in South Africa that are key, which is agriculture, which is health. We've also looked into education as a system itself, that 4IR technology is relevant. But also, we also talk to the creative industry, that the emerging technologies are taking the space of the creative industry, and where artists are no longer having the platform that was conventional, and there's digital platforms that are taking the space, and the art and so forth, where you have now digital art that you can put, that you can able to sell it to the world. You have visual reality affecting the industry. This is one of the examples of, and also looking into the services industry as well. The digital economy has taken over. Now, I want to go back to the minister speech yesterday and what the department is doing according to these recommendations that are put in place, and what's the plan that is in progress being implemented by the department and also other stakeholders, which is SOEs, which is aligned to the PC4R recommendation. So this is the recommendation of the PC4IR Presidential Commission that was put in place. Just to say that the commission's work has been completed, and it's now up to us to see that we implement these recommendations. Investment in human capital, AI Institute, platform for advanced manufacturing, secure and avail data, incentivize industries, build 4IR infrastructure, review policies, establish 4IR strategic implementation coordination council, such that our work is coordinated. Now, just going back to human capital, what are the key fundamental issues that we have to deal with? We need to deal with basic education, maths literacy. We need to ensure that our young people are equipped with the digital skills that is going to position them to participate in this economy. We need to have advanced digital skills that relates to universities, colleges, FETs. We need to have digital skills for society. People who are never been in tertiary education, but they also participate in this economy, and they exist, and there is opportunities for them as well. But what is very key and important is that our public service needs to be the public service of the future. They need to be reskilled. People in workplaces, in factories, needs to be reskilled to take advantage and to actually exploit opportunities that have now been presented. We've put together an AI Institute framework that we have started to implement. We have started negotiations and discussion with UJ. We're going to be launching these nodes. We're advanced in terms of the time frames. We're in a discussion with TUT, and we're looking into catalytic projects. First catalytic projects, digital identity, one government, which UJ is actually looking at. TUT, we're looking at automotive sector, and these are just the nodes that have been put in place. We recognize that we're not going to have one institute that is sitting in place. We need to be distributed across South Africa because there is pockets of centers of excellence that can be identified. And also here in Free State, we have to capacitate and ensure that we're able to identify programs that relates to working together in an AI ecosystem, which is the AI Institute. Tackling, very key, tackling challenges of our context. Now, in terms of advanced platform for manufacturing and new materials, we have put together a paper now. We have seen during COVID that some of the devices, after lockdown, there has been shortage of semiconductors. We're looking at semiconductors. We do have some of these materials locally that we can source. We need to tap into the value chain of the semiconductors. We can start somewhere, but we can able to supply all of these materials and components that are required for devices locally. Energy storage, very key. Housing, we've seen some of the models that have been displayed that you can actually 3D print your house. And this, we have housing challenges in South Africa. And we need to have such kind of innovation to solve this challenge using technology. We've seen in the exhibition, in terms of health, 3D printing of some of the parts that you can be well suited for your body, and these are some of the examples that we need to tap into. We have been looking into a strategy and framework that we have developed, and in consultation with the industry in terms of cloud computing, that government needs to move into the cloud. We need to move into cloud platforms. Government has to lead in terms of application of technology. We need to look into the big data analytic so that we can have a single view of government, sharing of information, sharing of biometric data, which is applicable across home affairs, it's applicable across the criminal justice system, local government, your hospitals when a child is born. We need to be able to track that view. And we're participating in terms of ensuring that we have digital identity that is well developed and a system that we can have a single view of, government. And this data is also very important for startups, innovators, and they can start using some of this data to provide solutions for our challenges. In terms of incentivizing industries, we have seen that some of the platforms that have been developed by our young people, we're not using them. And we have put together a platform where we can profile them, identify them, and start promoting them, that we consume our own technology. And this has been said by the minister here. And she's very passionate about it, and that we can also have a platform that we can take across in the continent. We can start sharing this platform that we consume what is local. In terms of platforms and also teaching our community, adopting technology, we need to move into electronic voting, very efficient. We need to tap into fintech, the way we distribute our social grants. It costs us a lot of money to distribute these funds. And there is technologies that we need to adopt, and we need to embed this innovation in communities. You can have spaza shops that can sell products via an e-commerce platform, but also you can also have this technology that can make consumers in locations where they can even order to be delivered. They can also have Wi-Fi hotspots where communities can actually start accessing platforms. This needs to be embedded in our communities. Now, in terms of digital infrastructure, connecting to what previously have been embedding technology in communities, we're looking into creating Wi-Fi hotspots across the country where people can go and have access through the SA Connect, connecting schools. The minister has asked here for the provision of schools so that those schools can be connected through the spectrum auction and obligations that we have with network operators, working together with them to ensure that they can connect schools. And that commitment has been made. And we're looking into connecting government institutions, local government, through CETA, through the SA Connect project, rollout of data centers, and phasing out of 2G and 3G spectrum, which needs to be refarmed for, where we can have advanced and high-speed connections for applications. The Electronic Communication Act is outdated. We need to have a digital, transformation or digital government 5.0 that's going to look into how we transform the way we do things. We have the e-government, which has now also been outdated. We have not been able to implement it. We need to look into the data policy, and we have consulted with the private sector, and we have been advancing in this. In terms of broadcasting, this has changed. All of these policies need to be reviewed. And you can see that you are now watching online platforms and which you can watch at any time, demonstrating that the space is changing very quickly. Last slide, how do we coordinate this? We need to work together with the private sector. We proposed the interministerial government that we can have a committee that we can work together in ensuring that we have a coordinated implementation of 4IR across South Africa and in all spheres of our communities. We need to work together with labor. In our consultation across provinces, we've had comments. We also had, truck drivers talking to us, the Association of, truck drivers, saying that AI is going to take their jobs. All of these concerns. But we know that advanced communities that adopt technology, they have more jobs. 4IR is not going to take jobs. Now we've seen that in terms of the e-commerce, how many jobs have been created. Someone just made an example yesterday that the fear of technology make us to think that our jobs is going to be taken. But if you are in your household and you want to wash your clothes, we appreciate using the washing machine. We don't wash it with our hands. We put it into the washing machine. We are able to wash our clothes very quickly. We don't say the washing machine is taking our jobs. Because while we were washing our clothes, we can able to do other things that are very critical. And this is the same as well as adopting technology to help us to do what is most critical with our time. Thank you very much, and this is the end of the presentation. Thank you.
Thank you very much, Ntate Sithole. Another round of applause for Ntate Sithole, please. Without really repeating what Ntate Sithole has said, but I think, I don't know, maybe Ntate Sithole by shaking or nodding, you will talk to us about our state of readiness. If we are to look at the electronic voting, perhaps in this room we may submit to you that let's test the state of our readiness as a country and let's try it in 2024. Shouldn't we? And let's see if we are ready so that we all have to sit at home and exercise our democratic right and vote in 2024 using our smartphones. Perhaps that should be a test that as a country we should be ready for it. Ladies and gentlemen, I want to quickly jump to the next presentation. I am going to request Ndate Mokalusi to join us. He is going to be helping us to understand the concept behind smart contract in the blockchain. Ndate Mokalusi. Just give him a welcoming round of applause.
This is running on. Yeah, no, next shop with let's come. Okay, testing, can you hear me? Good morning, my name is Lucky Mukalusi. I will be talking to you, we'll be discussing blockchain-enabled smart contracts for enhancing contractor payment solutions in the Free State Provincial Department of Education. How many of you, by raise of hand, how many of you know blockchain? Smart contracts? Okay, cryptocurrency? Okay. Let's have fun. Let's have a discussion about that. And then the technology says no. Just give me a second. Just want to see what's wrong. Sorry about that. Let's just give it a second and see what's wrong. I'm running my presentation from the cloud, so just bear with me. It's a bit slow. Okay, let's get started. The network is a bit slow on. It's Veracom. Sorry. Okay, I'll be introducing the case study. And then I'll tell you more about blockchain and smart contracts. And then the decentralized application that we've built called Easy Peasy, and then I'll give you a demonstration. We've been working on this project with Dr. Kurokos, Dr. Monyane, and Prof. Bankoli. Dr. Monyane couldn't be here. He's responsible for the constructions of schools in the Free State Department. So here a case study where his department is actually facing challenges with delays of paying contractors. So we looked at how we can enhance this contractor payment to make sure that we get rid of delays. And you can imagine contractors have employees. They have families to feed. And with such delays, contractors end up resorting to getting loans in order to mitigate the situation. So the idea is to achieve ideas of good governance and to address deficiencies in the procurement processes and to establishment of sound document management processes, which aligning them with the document process with objectives and policies as approved by the accounting officer. This is to ensure that there's efficient and streamlined document management processes with principles that are consistent and transparent. Yes, there are different stages on the document management process. I won't go through all of them. I want to focus only on the ones that I'm going to demonstrate on the application. The first part of the request for quotation. I want to zoom into that. So the first stage is basically the chief user may forward the request for quotation with specifications of services needed and the submission signed by the chief director. So the services in this case needed can be the building of a new school. So I subdivided the stages again. We can call them tasks. I call them stages. So let's look at the first stage. It's where now the chief user, initially that's the first person who starts the process. So the chief user will then send the RFQ to the chief director to be signed. And then the chief director will actually sign the RFQ and then send it back to the chief user. Where now the chief user will then set up a closing date together with the signed approved RFQ from the chief director. This is then sent to the suppliers on the central supply database, as we know it. So keep this in mind. We're going to come back to it when we do the demo. How did I get involved in this project? Well, I'm a postgraduate student with CUT. I'm under the supervision of Dr. Kurokos and Prof. Fermak. We've been involved in this project with, like I said, with Dr. Kurokos, Dr. Monyane, and Prof. Bankoli. So my title for blockchain, my title for my postgraduate studies is on blockchain smart contract, data provenance tracking application within smart manufacturing environment. So far, there's been several publications, international publications, to recognize the work. On my side, I have 14 years industry working experience, of which 6 I was a technical training manager. So one may ask, what is provenance? Well, provenance is defined as the place of origin or the earliest known history, which is tamper-proof, and its integrity can be verified across the entire supply chain. So what is blockchain? Well, blockchain is a decentralized system utilizing many computers around the world. Each computer is called a node. Each node can communicate with each other to form a consensus. Each node stores a copy of all the data records available on the blockchain. Data is stored as blocks which are chained together to make a public ledger. The code is stored in smart contracts, which are immutable programs that runs on the blockchain. So basically, blockchain is a write-only distributed database, which its transactions are trackable, irreversible, can only be added, not edited or removed. So basically, they're there forever. So the principles of blockchain is basically security, transparency, and traceability. Okay, meet easy peasy. I gave it the name easy peasy. From the phrase easy peasy meaning straightforward and easy. You don't need any skills to be able to go through the process of the submission of RFQs. No more excuses. Think about it, imagine a relay race where the success of the team to win the race depends on every individual member of the team. So the quickest, the quicker you finish the stage that you are in, then it determines the success of the team. So if you are delaying the team, that means we know who's delaying the team now. So let's look at the application quickly. And I want to go back to this slide so that it sticks there. I'll come back to it. So there are two sections. I just want to demonstrate quickly. On this side, we are going to have, so you'll notice that the login is actually one click. It's an advanced cryptographic authentication. I've hosted the decentralized application, so I'll give you the link. If you're more than welcome to go and crack it, good luck. So in this case, now we have the chief director. I just want to show it properly. And then on the other side, I'm going to log in as the chief user. Okay, I just want to show you, on the chief user, we are seeing something different. We have now where the chief user must upload the task, and whereas the chief director doesn't have to upload the task because it starts with the chief user, like I've said on that slide. Just want to go back to that slide. On the slide here. So chief user must start and upload and send an RFQ to the chief director to be approved. So let's do that. One thing I want to highlight is when you upload, there's an algorithm that checks for duplications and editing of documents, basically to keep out fraud. The same technology that is used, it's actually used for what is recently called the NFTs, non-fungible tokens, where the artists are now putting their music on the blockchain to avoid duplications and to make them unique. As you upload, basically that is exactly what is happening. So I have a sample of a quotation there. Let's upload as a chief user. There's a sample of the quotation. One thing I want you to pay attention to is, before I upload, that reference there, it ends with NKHG. That goes to that algorithm and checks that document and checks for duplications or fraud. So let's upload. So it ends with NKHG. So we upload that sample of a quotation and we submit. So what happens is there's a contract running in the background. When we submit, everything goes to the blockchain. We submit. Just give it a second. And then we are on stage number 2. We can see stage number 2. We can even tell who is responsible for that stage is the chief director. Now the chief director must now complete this task. So what I'm going to do is pay attention to that reference, now it has changed. It's, the first one, there was an initial one with the logo. Now is the quotation, that's YWDC. Now we give the chief director a chance to complete his task. So the chief director must send the signed RFQ back to the chief user. So we already know who's the next in line. So you don't need special skills to actually operate the software. Because and there were questions about, but now who must approve if a quotation is above a certain amount? There's no need for that. We already know who's the next person. So the chief user, the chief director now uploads this. So I want to make a copy of that same quotation just to show you that it can detect a duplicate. So I'll copy it. There is the copy. I'm going to upload only the copy. I just want to do it again. So I'm going for the copy, and pay attention to that reference. It won't change because it's a duplicate. So we submit. So everything goes to that algorithm and also the smart contract. We are on stage number 2, give it a second. It's on stage number 3. You can actually even see it there. It should change on the other side. You can actually see it there. We are on stage number 3. So for the chief user, I'm going to take the same document and edit it. So let's go and open that copy. And before that, I just want to back to the reference is still the same. So I'm going to edit that. Say someone wants to now change the digit on the quotation, but in this case, I'm not going to do that. I'm just going to put a dot. The dot, you can't even see it. So we'll let the algorithm do its work and see if it's been edited. So now is the chief user's turn, where he says the time and sends the signed RFQ back to the chief director. He uploads. Where is that copy? There. Remember, it was edited. So let's pay attention to that reference there. You submit. It goes to the blockchain. It goes to that algorithm, and then it checks. Let's give it a second. And that reference changes. So we can tell immediately it was edited. So this is basically to keep up fraud. So as the system, as it is right now, it can be used for decentralizing matric certificates, even our degree certificates, identity documents, voting. We can go as far as our mineral resources in Africa. This is basically a template for almost everything. Even when we looked at it with Prof. Bankoli, we can even go into the civil, where you can be held accountable for a building, a construction, where it collapses. We have all the information on the blockchain. It can never be erased. So it's running on a blockchain in the background. So all the transactions are recorded in there, so we know exactly what is happening in there. All the smart contracts are visible, so we can actually go back and hold everyone accountable. So future plans, as you can see, we need to add timers and see who's actually delaying the process. So that will be implemented in the future, so that everyone can be held accountable and keep on team. Thank you very much. Are there any questions? Okay, thank you very much.
Thank you very much, Ntate Lucky, Mr. Lucky Mukalusi, talking to us about the blockchain smart contract. Let's quickly invite Dr. Kuriakos to talk to us about the smart water bottling plant, and here with regard to the 4IR, how far are we with that regard?
Thank you, Program Director, respected dignitaries, fellow panelists, ladies and gentlemen, thank you very much. My presentation today is titled Envisaging Manufacturing in the Fourth Industrial Revolution, the case study of the smart water bottling plant. So the outline for the presentation, I'm going to focus on the current and future manufacturing trends. I'm then going to go straight into looking at smart manufacturing at CUT. I'll be splitting this into two portions. We'll be looking at the smart water bottling plant and also with a focus on the impact of the fourth industrial revolution on jobs, and then we'll conclude our session. So current versus future manufacturing trends. So at the bottom of the screen there, you see what is the current practice. It's referred to as a make-to-stock approach, where you have raw materials which go into your factories, they get converted into finished products, they go to a warehouse and then to a retailer and then back to the customer. But in the future, the trend is said to be one where the customers are the ones that make the orders, they get directly sent through to factories, get into finished products and then back to the customers. This kind of an approach is called a make-to-order approach, right? So what are some of the advantages of the make-to-order systems? Enhanced customization, greater product variety, there will be no or little excess inventory, there will be higher productivity, and it is also suited for your small-scale industries as well as your startups. However, there are certain challenges with the make-to-order systems, and that's where we come in with our research. The obvious drawbacks or disadvantages is issues related to bottlenecks due to customized manufacturing as well as production efficiency. This is what we identified as our research gap, and we set about researching through the water bottling plant case study. So the way the water bottling plant operates, it's given in this schematic here. The customer would place an order through an application, which then goes into a cloud or gets cloud, which forms part of cloud manufacturing. And then that is executed by a set of smart manufacturing units, or SMUs as one would call it. Right, so in our case, there will be 3 smart manufacturing units, the first of which is a water filling station, which will fill water into the bottles. The second would be a water bottle capping station, which would cap these bottles. And then finally, we are looking at a storage and delivery. So we've completed the first 2 stages. We're looking at the third stage and seeing how we can best do delivery and storage and delivery. That forms part of research called, referred to as last mile logistics. So here I just want to see if I can show a quick video of the operation of the plant. So once the orders get processed, they come to the water filling station. Here they do get filled into the bottle. So presently we have devised it such that we can bottle 500 ml as well as 300 ml bottles, but this is subject to change depending on the requirement of the customer. And from the first SMU, it goes into the second station where it gets capped and then to a storage section. So this is a very quick demo of the operation of the plant currently. And as I mentioned, we are looking at seeing how we can actually go on to the third section where we are looking at last mile logistics. So keeping this in mind, this is the one area where we are looking at the research aspect. We are looking at elements like production efficiency, reduction of bottlenecks in the production. Then we come to the second and more societal impact of 4IR. That is the impact of 4IR on jobs. And this relates directly to what I think Dr. Naidu spoke about earlier in our plenary session. The needs of the different parts of the world with regards to the fourth industrial revolution are very different. And I think we in Africa need to be aware of that. So one of the most important concerns is that the fourth industrial revolution will result in quite a bit of job loss. So how do you now mitigate the impact of job loss caused by automation? So what we have developed with the case study of the water bottling plant is developing a software-based protocol where we can categorize jobs that can be best done by machines and those that can be best done by the human workforce. So the protocol works in a way that if you provide an input looking at the number of constraints, so in our case, you're looking at the amount of water in the tank, the number of caps, the number of bottles, the total time to bottle. If you input all those constraints, then the output is a data sheet which basically tells you which jobs are best done by machines and then which jobs will be best done by humans. And now, once we've identified that, we can then train or reskill the existing workforce so that they can achieve these specific tasks which will be best done by human beings. So envisaging a fourth industrial revolution manufacturing plant, we would like to see that, yes, there will be room for automation, but at the same time, through human-machine interfaces, we would like to see how best a human being can be involved in the manufacturing space and thereby contribute to the value of that process. So to conclude, I'd just like to give a quote from Nikki Word. She is based in South Africa. She is one of the global top 50 speakers in disruptive technologies. And in her book called Disrupt Yourself or Be Disrupted, she states that you cannot stop the fourth industrial revolution, but you can influence its direction and the impact in your life. And I think seeing from everything that we've heard thus far, and I'm sure going to hear further on, we are all in a space where we would like to change how the fourth industrial revolution has an impact on what we do. Right. So I'd like to thank the Center for Sustainable Smart Cities at CUT, my co-collaborators, the National Research Foundation who funded this project, and a big thanks to the organizing committee of the 4th IR Summit for giving me the opportunity to speak before you. Thank you very much.
Thank you so much, Dr. Kuriakos. Let's give him another round of applause, please. So, while many of us are still trying to come to terms with the hiking petrol prices, our next speaker will try to calm us down because there is a possibility of driving a car that doesn't require diesel or petrol. The solar car project, Professor Lewis, can you calm our nerves?
just want to see if my slide is working. There we go. All right, so as introduced, I'm Prof. Lewis. I'm also the Director of Smart Cities at CUT. So I'll just briefly go into what the Center for Sustainable Smart Cities is, and then I'll quickly discuss the solar car project as well. So we can see that the Center for Smart Cities at CUT is mainly aimed for the 12 United Nations goals. So we are looking at 17 goals, to see if we can address them through research and projects at CUT. And we are then more focused on number 7, 9, and 11, which is environment sustainability, ensuring sustainable smart cities, innovation, industry, and infrastructure. We also focused on Industry 4.0, as we can see some of the projects that were presented here as well. And we also look at, especially in the Center for Sustainable Smart Cities, we look at interdisciplinary research. So there's a few projects, just to quickly show you the projects we are looking at. It's smart farming, smart manufacturing, renewable energy. All of these then try and address that 17 United Nations goals, but we also have international publications in this project, which means we are the experts, the international experts in this field as well. And that is kind of important, that we set up a expert base, international expert base in South Africa, but also the Free State. So one of these projects is then the Solar Challenge. So the Solar Challenge is an international challenge. It's what I call the Formula One of solar. So it's where all the research are being done. The future is now. If you look at Formula One in the past, that's where they developed ABS brakes, traction control, and so on. So we're now in that section where we develop the technologies that you will see in a few years in your cars. So this year we're going to go again from Johannesburg all the way down Kroonstad, Bloemfontein, Gariep. We're going to go down Jeffreys Bay, and then we end in Cape Town. So how the challenge work is, let's say for day one we go Johannesburg, Kroonstad, but you say that's only 2 hours drive, but we actually go halfway, and then we turn off to Sasolburg. And we drive all day long to Sasolburg and back, N1 Sasolburg, N1 Sasolburg, and then by 5 o'clock tonight we have to be in Kroonstad. So we want to see how many kilometers we can reach every day. So the one that drives the furthest in this 8 days kind of win the challenge. So even though the road looks short there, it's not really that short, because we do loops every day. We drive for 8 hours every day and see how far we can go, only using the sun as power. So you can't recharge at night your batteries. You're only allowed to drive with sun power, nothing else. So only the sun. So this is the team, and there's a few students that left already CUT, and there's some that's still here. So again, without humans, we can't, it doesn't matter what your technology is, there is people behind the technology. And this is my team. They are world designers, world experts in designing cars, in designing electronics, making the car work. So there is my team. So what do we do? How do you design? How do you go into a car? Now, car name is Ntsu this year, so it's the eagle. So we're going to soar, and if you look at the eagles, they do soar without using a lot of energy. So that's the idea. So we start with a CAD design concept of a CAD. Then we will build a model of the car, and then after that we'll build a 1-to-1 scale model of the car, temporary, to see if you actually fit in the car and so on. And then thereafter, we will do the welding. Let me just go up one again. Sorry, yes. Let me just see what's going on here. All right, so we do the design, the frame then the frame is then done, crash test on. You can see there's all the strain tests are doing software. So we do this at CUT as well. So make sure that if there should be an accident, we're not planning for an accident, but if there is an accident, the driver is safe. So we have 5G crash tests done in simulation on the car, make sure everything is safe. This is also one of the rules of the race, that if there should be an accident, and if you look at Formula One the other day, the Alfa Romeo car that flipped. I'm an Alfa Romeo fan, so it was, but you can see that we have the same halo system, the same technology that's in Formula One cars we do here in the Free State, simulations to make sure that it's acceptable, the driver. We can see that's a side impact, the one there in the middle. There we go. There's a side impact, frontal impact, and you can see the slight bending that the frame gave, but this is on 5G, so it's five times the weight. This car is safer than whatever car you're driving at the moment, so it's safer than a Volvo. All right, so then after that, we built the frame, and we built it very lightweight. You can see I'm not that strong, but I picked up the frame there, so it's kind of lightweight frame. There we are still building in the construction process, so you won't see the final project yet, but we are launching 19th August. So we can see there is all our designs. We also have full suspension. We have KPAs, Ackermann's curve for the mechanical guys. It means the one wheel turns further than the other one if you go around corners, meaning this car can handle like a Formula One car. It also has KPA for best traction, so that we can do the mountain passes as fast as we can. So we have to drive the mountain passes, again, fast but safe. If you have a safe car, you have a fast car. All right, so what did we do in the previous race? So this is kind of how the previous car looked like and what happened in the previous race. We can see there's the previous team as well. Our previous car completely different than the new one. There we are driving it along the route. Sorry, I just want to... There we go. It's me on the motorcycle there on the side, making sure the drivers are safe. So we can see there on the speedo. I started in Bloemfontein, reset the motorcycle. When I came back to Bloemfontein, it said 4,700 kilometers. So I've driven 4,700 kilometers next to the car on the motorcycle. I kind of felt that weak. The drivers, we do change the drivers every 2 hours to keep them fresh and so on. There we can see there, this picture here. We are at Cape Agulhas, the most southern point of Africa. So all the teams around the world, they would drive with us, and we can see there in the video, all the teams are charging batteries, they're standing in the sun. They ran out of fuel a bit, so they are recharging their batteries in the sun during a lunchtime and so on. So that's also the route we did in 2018. But now, it's not just fun and games. Let me just go to the next slide here. What did we do then after the presentation? We went and write up some papers on what we've learned during that time. And we presented in Italy, in Torino, at the Electronic Car Conference. So my first presentation I did after Lamborghini, and the second presentation I did between Ital Design, that's doing the Audis, and what's that English car? Bentley. So I did it between Italian Design and Bentley. So we are in the forefront of car design here in the Free State, of future car design. So I'm just briefly going to say what we did during that time. The one was a cover material. You can see that first car of ours were aerodynamically shaped. Let me just go to the next slide there. So we saw that obviously a block is not that nicely shaped. But if you go a little bit of aerodynamically shape, let me just see. The video will play through. All right. So we went through a little bit around the car to make aerodynamically shape, which means we have to just look at cover material. So what will happen in the future is, if you buy a new electronic car, you might have solar panels on the roof. We can see there's our shape. It's a little bit better aerodynamically now. So you might have solar panels on the roof, and there needs to be a plastic covering the solar panels. So you want to drive from Bloemfontein to Cape Town with your new electric car. Currently, you have to recharge your batteries in Kwilsberg, and you have to recharge it along the route. You're going to drive 7 days to Cape Town because you have recharge in every town. In the future, the solar panels on your roof might charge as you drive. And we need to see what plastic, what polymer will be the best. Even for your house, what type of covering can you put on your solar panels to protect it against hail or storms? And then this is what we kind of did. So we looked at different type of plastics, and this is what we presented as this international conference, this IEEE international publications, is what plastics are best covering your material. We also did custom setups to test it. See if this video plays. Okay, that video doesn't play. So we made an instrument that will actually, there we go. An instrument that will test this system for you. So not only do we look at the plastic, we also design instruments. There's the instruments that test if the sun is moving across. You can see there's our electric sun, and then during the day it will show you how the sun moves across your panels, indicating what angles are best. Is the plastics going to work? So we also do instrument design. All right, and then that was just the conclusion for this presentation that we did. The second presentation that we did is we have this stations that measure solar power around the world. So one of them, and this one is sustained by us, the smart city, so it's here on the CUT roof. There's one in every city in the world. So normally when you get that data that shows you how much solar is in which part of the world, you can normally get a little map showing you Africa's got so much power, Europe's got so much power. It comes from the actual sensors that we maintain physically here on the roof. Again, in your future car, if you want to drive to Cape Town, you want to know what the weather is, how much solar radiation is on the rest of the road. So your car can tell you, slow down, you're not going to reach Cape Town. You can only do 110 kilometers per hour instead of 120. If you do 110, you can go all the way. If you do 120, you'll have to recharge along the way. The problem with that is you need that sensor, and you can see the sensors highlighted there on the roof. It's the same, it's on the roof of the car. So this car traveled with the solar car in 2018. And we compared this data with the same sensor as the ones that's in the cities, around the cities. So that one day your car doesn't need the 100,000 Rand sensor on it. Your car can use the city data, so it can use the closest city data. So it's, again, cloud computing, blockchain, all that stuff. So your car will know GPS where it is, and it will compare to the route that you planned. And it will say, how is the radiation for your solar panels along the route? So nobody's done this before, because nobody's driving through a country to see what the radiation is along the way. And then we did it across the road, and because Africa is nice, South Africa is nice, from Joburg to Cape Town, we go through all the weather conditions, from the deserts in the Karoo to Joburg, which is more, there was just some mass with it. So we kind of saw that your 70%, you can see the correlation is quite close. You don't need a sensor. What it basically comes down to, you don't need a sensor on the roof, especially in the Karoo. In the Karoo, the closest station was 217 kilometers away, which is far away. But in the desert, it doesn't matter. There's not a different cloud cover 270 kilometers away from where you are driving now. So where it was different is obviously places where it's more mountainous. So we can see in the Karoo, and that's how the picture looked like when we drove through it. Remember, 2018 was the water scarce part. So that was basically the same. Bloemfontein was the same. There was a dip at, what's the place, Graafrenet. But those of you that drove to Graafrenet, you know there's a little mountain pass just in between. So again, information we're giving the world. So in the future, they would know that if there's mountain passes, you will need to get sensors in that's maybe along the route, especially when there's a mountain or trees along the path. And then also rain. We had a dip there between the closest station and what we measured, because we know in South Africa it might rain in Bloemfontein, but it won't rain in Redesburg. No, there's a storm specifically on our space. Where I've been in Germany now for a month or 2 months. I've been there. When it rains in one part of Germany, it rains all over Germany. So in South Africa, it's a little bit different. So again, stuff that needs to be focused on in the future if they're going to use this type of data. And you can see there was a big storm that day. But most of the spaces we saw, it's the same. So we did 2 international publications. We also had a master's student just finishing his master's on the project. And obviously, we're going to do a few more research questions for this year's race. So we're already planning some research for this year. If you want to join us in sponsorship, if you want to connect your company to a green image, we are the green image, I think, and we are the future, and we can see we are publishing worldwide, so you will get some exposure at this IEEE conferences as well. I just want to say thank you to the sponsors we already have, and that is me. Thanks.
There you have it, Prof. Lewis. Another round of applause for him, please. More so for the solutions that are to be provided for all of us. Ladies and gentlemen, we are managing time, and in doing so, we are going to move to the next item on our program, which now it's going to be the commissions. So we're going to be breaking away for commissions. And I'm sure it is at commissions where all of us would have enough time to engage the content that has been shared between today and yesterday, so that all of us were able to dissect that content. So there's going to be Commission 1, Commission 2, and Commission 3. And this Commission 1 would look into education, training, and employability. We will be in this venue. It will be facilitated by Dr. Nokweku, as well as Professor Sitlalentwa from CUT. Dr. Nokweku, he is with the Department of Distia. So that commission will be in here. There's then going to be presentations during those sessions. Commission 2 will look into health care. It's going to be at the Prosperitas Auditorium. It will be facilitated by Prof. Mashele. So if you are into the healthcare and you would like to get more on that, please make your way to Prosperitas Auditorium. Another commission which will also be taking place here will be, there will be presentation on preparing youth for careers in 4IR, and there will also be a presentation on unlocking Free State industrial potential through business incubation programs. There will also be at the Prosperitas Auditorium, Dr. Osayande will look into the nuclear medicine and all the details around issues of nuclear medicine. I mean, obviously this talks to advancing nuclear medicine. And then Prof. Robin Pillay will also look into the digital health, as well as Prof. Elisha looking at the smart wheelchairs. We are all encouraged to participate and really engage one another during these commissions. Commission 3 would look into the agriculture. That commission will sit here as well. It will be facilitated by Dr. Masiteng, who is the HOD of the Agriculture Department, as well as Prof. Sidibe from CUT. And then after lunch, we will all come back here for 4, if not 5 items to close our summit. For this morning and this session, ladies and gentlemen, I'd like to thank each and every one of you. We're going to break for our commissions while we have tea. Thank you very much.
Thank you very much.
Thank you very much. Relax.